All right, watch. The cells of the immune system, white blood cells, are formed in a couple of places. Number one, the bone marrow, the inside portion of the bone. Bone is living tissue. You got me? The second place they're formed, white blood cells, are lymph nodes. More on that later. Number three, the spleen. The spleen is part of the lymphatic system, right? So the spleen, a couple of things it does. Number one is it filters old red blood cells and destroys them. And it also makes white blood cells. In young kids, the spleen produces red blood cells too. That's why when a kid damages his spleen, the doctors will try to repair it versus taking it out. Otherwise, they can become anemic. So, yeah. All right? So, watch. All blood cells, red blood cells, white blood cells, originate from what are called hematopoietic stem cells in the bone marrow. Who's following this? Right? Are all red blood cells the same? Yeah, no, what is it?
All red blood cells are the same. Yes.
All red blood cells are the same, right? They do the same function, right? And then you got platelets. You know what platelets are for?
No, but they're all the same.
They are. Right. Platelets are, under a microscope, look like little plates. Just like Piglet was a little pig. Remember Piglet? The wonderful thing about Tigger is Tigger's a wonderful thing. His top is made out of rubber. His bottom is made out of spring. He's bouncy, trouncy, bouncy, trouncy, fun, 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 fun. Ready? Platelets are involved in blood clotting. Say yeah. In order for a clot to form, platelets have to stick together. Guess what aspirin does? Yeah, how does it thin your blood?
Makes them not stick.
It makes platelets not stick together. Like that? Not really. Okay. Are white blood cells different?
Yes.
Yes, they're different. They're called white blood cells. And they're different. Because you're exposed to different bad things. Say yes.
Yes.
All right. This is how you remember it. The different types of white blood cells and how numerous the white blood cells are. It's never let monkeys eat bananas. Are you with me? So the most numerous of the white blood cells are called neutrophils. The second most numerous are lymphocytes. Say yes. Then you have these things called monocytes and eosinophils. Say yeah. And basophils. These are the types of white blood cells. Most numerous to least numerous. The most numerous are the neutrophils. Say yeah, guys. So, when you go to the doctor and you get a CBC with a differential, what the machine does is it counts up the total number of white blood cells, and then that total is made up of the different number of white blood cells. Do you follow that? And in advance, I'll explain more. But based on which white blood cells are elevated or depressed, a doctor can determine whether you're having a bacterial infection or fungal infection or you got a tick infection. Say yes. Or it's allergy. Tell me you got that. Okay. So where do you make these white blood cells? Primarily in the bone marrow. The bone marrow and lymph nodes. Say yes. And collectively, those white blood cells are called leukocytes. So here we go. Are you born with white blood cells?
Yes.
Yes. Otherwise, you'd pop out of your ma's womb and you'd die from fulminating infection. You ever see The Boy in the Plastic Bubble?
Yeah.
With John Travolta?
Yeah.
Boy, that was a made-for-TV movie. Thank God. Didn't have to pay any money to watch that. Anyways, he was born without an immune system. Are you with me? So, if he came close to anybody or touched anybody or he got infected with germs, he would die. So, you're born with these white blood cells. These guys right here. So, these white blood cells are part of what is called your innate immunity. You're born with it. Who's with me? I like to refer to these guys, these white blood cells, as the sons of anarchy. They'll kill anything. You got me? So these guys drive around on their Harleys and they look for bad guys or good guys. They look for bad things and kill them. Say yes.
The leukocytes.
All of these in a little rectangle. Say yeah. So, what color are white blood cells? Very good. So that's why pus is white, because it's a collection of white blood cells. Say yes. Okay. The lymphocytes are different. The lymphocytes have to be programmed. So in order to program lymphocytes, you have to come in contact with that antigen or pathogen. Who's following this? You with me? So let me explain these guys. So the lymphocytes are divided into three types. You got T cells. You probably heard of T cells with respect to HIV, right? And then you have B cells. And then you have NK cells. NK cells stand for natural killer cells. Right? Did I explain this?
Yeah.
Oh, I did?
Yeah.
Okay. So, well, I'm going to explain it again because it's important. So, these guys, in order to be activated, in order to kill something, they have to be programmed. And write this down. There are millions and millions of different T cells, B cells, and NK cells. And only one B cell, T cell, or NK cell is specific for a specific antigen or pathogen. Who's following this? And what determines which antigen or pathogen they're specific for is based on the type of receptors that are embedded in the T cell, B cell, or NK cell's membrane. Say yes. You're following this. Okay. So here we go. I'm going to explain to you now how a vaccine produces immunity. Are you ready? Here we go. The most common type of pathogens that you deal with are, again, bacteria, and viruses. And you'll learn more about this in microbiology. But watch. Here's a bacteria. How do you know it's a bacteria? Because I wrote bacteria. Now, your immune system doesn't look at that and says, hey, that's Pseudomonas aeruginosa all day. Right? What they do is they look at the receptors that are embedded in the cell wall of that bacteria. So the only thing that the immune system responds to is the type of receptors that are embedded in the surface of this bacteria or virus. Are you with me? Where does all lymph fluid have to go before it gets dumped into the right side of the heart? It's got to go through a lymph node. Say yes. Write this down. Guess what lymph nodes produce? Spitball in here. Lymph nodes. Lymph nodes. Here, wait. I'm going to give you a hint, just a real quick one. What do lymph nodes produce? Right, they produce lymphocytes. Say yes. So these guys are part of your specific immunity, and remember, you have to be they have to be programmed. Say yes. Who's with me, guys? Okay. So watch. Somebody hacks a loogie on you, right? I mean, a real hawker, right? Right? Deep inside. And they're like, pooey, right? Right on your face. Isn't that pleasant? Anyways, if that bacteria gets into your body, white blood cells, sons of anarchy, go and attack it. Do you follow me? And then they take that eaten bacteria to the nearest lymph node. Say yes. How many people have done good on this in this class and then they took their quiz and put it on their refrigerator? Nobody? I used to have a student, if she did good, she would take a picture of it and upload it to her Facebook. Tell me nobody does that.
Nobody's on Facebook anymore. I don't have Facebook anymore.
Can I tell you something? I had a student, she was on Facebook. She was on Facebook in class, so you know what I did? I brought up her Facebook page. I said, what are you doing? Should we do that?
Nobody's on there anymore.
Why?
Mass exodus. I'm on there.
Why? Wait a minute, how did this happen? We were doing good. I'm losing control of this classroom. Guys? Okay, talk about Facebook later. Watch. The white blood cells, the sons of anarchy, circulated, they ate the bacteria. And then the white blood cell goes to the nearest lymph node. Who's following this so far? And what they do is they take, watch it, when they eat the bacteria, they take the receptors of that bacteria, watch it, and they put it on the white blood cell membrane. Say, look what I got. Who's following me? Yes.
So that way it knows how to destroy the bacteria it needs to.
Yeah. So how many people got this so far? It goes to the nearest lymph node. All right? So watch. Now this is the important piece. you have a B cell. How many different B cells you got? Gazillions, right? Don't even want to talk about it. And each B cell has specific receptors embedded in its cell membrane. Now, for simplification, I'm not going to draw millions and millions of B cells. I'm going to draw 2. So watch.
So you will never find 2 that are the same?
No. Is this B cell different than that one? Because the receptors are different. Say yeah. Now watch. Now we're in the lymph node here. So watch. You got a white blood cell that ate the bacteria. And what did the white blood cell put on its cell membrane? The receptors. These are supposed to be kind of round. So which B cell is going to interact with this white blood cell and those receptors? This one. So what will happen based on the matching up the shape of the receptors, this B cell is going to match up receptors. Did you see how I moved that? Wasn't that pretty good? I should make an animation. Are you ready? Watch it. Write this down. This is the critical piece. When a B cell comes in contact with this pathogen's receptors, it gets turned on. And that B cell divides. And it divides into 2 types of cells. It divides into plasma B cells. Who's with me? And memory B cells. What do memory B cells do? Memory.
Memorize.
They memorize what that B cell came in contact with. See, who's following me? Who's with me? And then the job of the B cell, the plasma B cell, is to begin to produce proteins called antibodies. Write this down. Antibodies are proteins produced by plasma B cells. Who's with me? And it is the job of the antibodies to seek out that particular bacteria and destroy it. So antibodies destroy antigens or pathogens. Who's with me? This is so important. This next statement. Watch. Somebody goes, "Achoo!" Right? And you go, "Hey, I got it." Right? If you've never been exposed to that bacteria or virus, you don't have a B cell that has been turned on. This process of turning on an inactive B cell into an active B cell takes time. It can take weeks. Say yes. In the meantime, you get that bacteria or virus in you and you get sick.
That's why the flu is like 2 weeks.
Who's following this? Yes or no? Now watch. You need to get this. When you are first exposed to something, oh no, uh-oh, look at the wheel. The wheel on the bus goes round and round. I'm hoping so. Yep. Okay. Watch. Guys, please get this. On your first exposure to that pathogen, you only make a few plasma B cells and you only make a few antibodies. Right? And because you don't make them very fast, that virus or bacteria can grab a hold and you will get sick. Yeah? Okay. So watch. But what did that active B cell, it made plasma cells and then it divided into plasma and memory cells. So this is the kicker. So here you have a memory cell. And let's say, for example, that you got sick, right? Right? Somebody coughed the flu on you and you didn't get the flu shot and you got sick. Well, that process of turning on a B cell happens, so now you have memory cells. Who's with me? And let's say that you are now exposed to that same strain of the flu. That white blood cell, when it comes into you, it's going to eat that flu virus and it's going to present the little proteins on its surface to memory B cells, specific memory B cells. And those memory B cells are going to interact with that receptor. Say yes. And it is going to divide into a massive number of plasma B cells. What do plasma B cells produce? What do they produce? What do they produce? Antibodies. So this massive number of plasma cells will produce a gazillion. How do you spell gazillion? Who cares? A gazillion antibodies. And watch, this is very important. Instead of producing only a few and taking weeks to do it, because of the memory cells, you will produce a gazillion antibodies in hours or days. The result is that you will produce those antibodies, they will circulate in the blood and lymph, find that bacteria or that flu, whatever it is, and it will attack it and destroy it before it infects your cells. Say yes. So everything that you've ever been exposed to in your life, you have a B cell that will protect you. If you've been exposed to it, you now have memory B cells that are specific for that antigen or pathogen. It will ignore any other antigen or pathogen, and it will only attack that one. Say yes. So watch. Only chicken pox once? Well, you should only get it once in your life. So if you're exposed to it, you shouldn't get it again. However, sometimes if you get a mild case of the chicken pox, that chicken pox, that varicella virus, it likes to hide out in spinal nerves. And that's how you get shingles.
Can you get shingles more than once?
Yes.
How come the memory cells and how come the plasma B cells don't shut that down?
Plasma B cells have a hard time getting into the central nervous system because the central nervous system and nerves don't have a lymphatic system. That's why anytime you get a bacterial infection in the nervous system, it is bad for you. Like bacterial meningitis, you don't want that. You want to read the textbook. How many people followed this so far? So watch. Watch. Let's say, for example, you go to Walgreens in September and October, right? And that's an arm with little bear claws for fingers, right? And they inject you. It's just bad. Yeah, that's the flu shot. And they inject you with the flu virus. Tell me you got that. Now watch. The flu virus that you get is dead. You can't get the flu from the flu shot. If I ever hear you say that, I'll mark your whole life wrong. Right? So watch. Remember, your immune system doesn't know that you went to Walgreens and got a shot. All your immune system knows is that it is a pathogen. Tell me you're following this. So when that flu gets shot into your arm, ouch, white blood cells come in, gobble it up, and what do they do with the receptors? They place it on its surface and bring it to your lymph nodes. What do you produce in your lymph nodes? Lymphocytes, specifically B cells. Say yes. So now you got a white blood cell that in this is yellow, and it has embedded the receptors of that flu virus on it. Tell me you got that. A B cell is then going to match up receptors, and that B cell is going to get turned on. Say yes. And when it gets turned on, it's going to divide into plasma and memory cells. And then it's going to seek out the shot flu virus and destroy it. But because it is dead, you will not get sick from it. Say yes. But when the B cell comes in contact with these proteins and it gets turned on, it divides into memory cells and plasma cells. Do you make a lot of antibodies the first time? No. But now you got the flu shot. So now somebody hacks a loogie on you, right? What do you have lying in wait? The memory B cells. So with the memory B cells, when you come in contact with the real deal flu virus, it will divide rapidly into plasma cells, make a gazillion antibodies, attack it and destroy it before you get sick. That's how all vaccines work. You're getting what causes the disease in the shot, but it's weakened or dead, so you can't get sick from it. However, the smallpox vaccine is a live vaccine. So you can actually get smallpox if you get the smallpox vaccine. You guys are all too young to remember. When I was a kid, I had to get the smallpox vaccine. And it had a little crusty thing, and it kind of shot you in the arm. Right? You guys don't remember. Do you remember it? Yeah, I remember. Yeah, I cried.
That's the one that makes the scar, right?
Yeah. You got it?
Yeah.
But they do it here when you're a baby.
They give it to you when you're a baby?
I have it too.
I don't know, but
Oh,
I
really?
used to get it twice.
Oh, wow.
You all babies have the same mark in their arm.
Were you born in the United States? Where? Yeah. Did you get the BCG too?
No, I have to. They told me that. What is that?
That's the shot against Tuberculosis, TB.
Oh.
Yeah, they told me that when I get it, it's gonna come back positive, so I have to go get an X-ray.
You got to get a chest X-ray. You should never let them test you ever. I saw some people who had the BCG. It was a mess.
So I tell them not.
Tell me you got this.
Well, wait a minute, why was it, what happened with the test? You saw people, what happened?
What?
You said never let them test you because what happened?
They'll get a really bad inflammation. The skin can actually just kind of get eaten away from that because you get a massive immune response. So don't do it. How many people followed this? Guys, that's how all vaccines work. All of them.